Okay, in question 8, alright, in fact, question 8b, this question we have to solve it by taking log on both sides of an equation. Alright, so when do we take log on both sides of the equation? Okay, on both sides of an equation. Alright, when do we do that? Alright, we usually do it when the power, okay, the unknown exists in the power, and we want to solve for the power, and we have one term on each side of an equation. Alright, so you may have a very long equation and then the unknown exists in power, and you are able to conveniently reduce it to one term on each side of an equation. Alright, recall E is not an unknown, E is a numerical value, just like your pi. So alright, in this situation we take log on both sides of the equation. Okay, if you recall in laws of indices, the topic in your worksheet, alright, we have done solving. Alright, if we have unknown power, usually, okay, like this example here, we can solve it by converting into the same base. Okay, so when we compare the powers, we can conclude that x is equals to 2. Okay, in this case, this is an example. Alright, we take log on both sides when it is impossible for us to convert into the same base. Okay, conveniently convert into the same base. Like for example, in this question, the base is 5. But for E, we can't convert it into base 5. Alright, without any complexity in the working. So in such situation, we take either log base 10 or natural log based on the requirements in the question. So in this question, we have an E here, so it is better for us to use the log of base E, which is ln ln. Alright, so we take natural log on both sides, okay, of the equation, equals to ln E. Alright, so by taking log on both sides, right, the equation will still be equivalent to one another, because if you recall, there's this law of logarithm, log m will be always equals to log n, provided both log are of the same base. Okay, so by doing this, they are still equal, and then we can go ahead and solve it. So log base E is to E will give us 1. Alright, and on the left hand side, the power, we can use power law to bring down y squared minus 2y. Okay, multiply to ln 5. Alright, and then from this step, we can divide ln 5 over to get y squared minus 2y equals to 1 over ln 5. Okay, recall ln 5. Ln is something that you can press on your calculator, ln 5, to get a numerical value. So this 1 over ln 5, right, actually give you a numerical value with a lot of decimal place. So you can treat it as a number, as a constant term for this quadratic equation that we have now. So if we shift over, negative 1 over ln 5 equals to 0. Okay, so now we solve this quadratic equation here. Obviously, we can't do factorization because you can't break down this 1 over ln 5 into whole number factors. So we go straight into using the general formula to solve it. Okay, general formula. Plus minus negative 2 square minus 4 times 1 times negative 1 over ln 5. Okay, and you have a square root over and over 2. Okay, so you can press your calculator and you are supposed to have 2 answers for y because of the plus minus here. So the first value that you can get is a 2.27331. The other value that you can get is negative 0.27331. Alright, and we round off to 3SF. This will be 3.2. Okay, 2.27 and this one should be negative 0.273. Alright, and at this stage we need to check our answers by replacing these values back into the original equation. Alright, you can do it by calculator, just press it out, both values, see if you get equals or close to E. Or another way is by using concept, alright, concept, because for these two answers, one of them is a positive value, one of them is a negative value. Okay, so for 0.273, if we substitute into the power of 5, we will get a negative power overall. Okay, you can press your calculator, 0.273 square minus 2 times 0.273, you'll get a negative power overall. Alright, which 5 to a negative power will actually give you a value that is less than 0. Okay, if you press your calculator, so it shouldn't be equals to E. That's why we reject this negative answer, and we only have 2.27 as our answer here for question 8b.